Another gas law is named after Avogadro, the same guy who brought us Avogadro's number. Here we're concerned with having the amount of gas change. What happens if that changes? So what Avogadro did is he measured the volume of a gas at constant temperature and pressure while varying the number of moles of gas in the sample. So he's adding gas. So you start with, like 0.11 moles of gas, and that had a volume. And you add more gas, put more gas in the container, keep the pressure and the temperature constant, but let the volume change, and measure the new volume. Just keep adding gas, the volume increases. This makes intuitive sense, doesn't it? You can think about a balloon. Yeah, there we go. Think about a balloon. You blow more air into the balloon gets bigger, right? Kinetic molecular theory says we're adding gas molecules, and to keep the pressure constant, they're going to be hitting more. We have to expand the volume. So the relationship is linear. This was first stated by Amedeo Avogadro, and it was these studies with gases that led to the number, Avogadro's number, and the concept of the mole. So Avogadro's law says the volume of a gas and the amount of the gas in moles are directly proportional. Very important to note that we're quantifying the gas in moles and not in grams. It's not mass, it's moles. How many particles of the gas? So here's the expression of Avogadro's law. V1 over N1 equals V2 over N2. This one? So let's do a problem. 4.8 liter sample of helium gas contains 0.22 moles of helium. How many additional moles of helium gas must be added to the sample to obtain a volume of 6.4 liters? So we're going to make a table. So that's what we do. 1 and 2. 4.8 liters. It doesn't say what that is, but we should recognize from the unit liter that that's the volume. Contains 0.22, bless you, moles of helium. Bless you again. Moles is given the symbol N. Don't ask me why, because I don't know. So N is number of moles. And the other number that we're given is 6.4 liters. So stick that in here, 6.4 liters. What could we solve for then? N2. So awesome. Bless you. Bless you all day long. V1 over N1 equals V2 over N2. Again with the stupid fractions. V1 N2 equals N1 V2. I'm solving for N2. Divide by V1. Those guys cancel. Divide by V1. So N2 equals N1 times V2 divided by V1. So N1 is 0.22 moles. Volume 2 is 6.4 liters. And volume 1 is 4.8 liters. The liters cancel. So N2, 0.22 times 6.4 divided by 4.8. 0.29, I should have two sig figs, 2933, and it goes on and on and on, moles. I found N2. Does that answer the question? Does it ask how many moles of gas are in there? No. How much do you have to add? What did I calculate? The amount of moles at this new volume. So this is the moles at the new volume. This is the moles at the first volume. How many did I add? Subtract. So I need to take what I calculated, 0.2933, and subtract what I started with.
You have to use the 3-3.
You don't have to use the 3,3, but it's good practice. So when I subtract, I take the amount I end up with in moles minus what I started with. That gives me how much I needed to add. And if we're thinking about significant figures, it's just going to be 0.07 moles. Make that a better 7. So this is a problem that involves a little bit more thinking. We still were able to approach it by make the table, plug the numbers in, but then stop and look at what you've got. Does it really answer the question that you were asked? Any questions?
When variables are indirectly related, it seems like you multiply them together, but when they're direct, you divide them. Will it generally be like that? So
That's the nature of an inverse relationship, yeah. Let's do another one. A chemical reaction occurring in a cylinder equipped with a movable piston produces 0.58 moles of a gaseous product. If the cylinder contained 0.11 moles of gas before the reaction and had an initial volume of 2.1 liters, what was its volume after the reaction? So we've got 0.58. I'm just going to go through blindly and label stuff. So that's N, that's the number of moles. That's how much gas was made. If the cylinder contained 0.11 moles before the reaction and had a volume of 2.1 liters. So do you see that 0.11 moles and 2.1 liter go together? They go together. Is it okay that I call them number 2, even though that was the initial thing? Yeah. It's fine. 1 and 2 are just labels. You could use 17 and 59 if you wanted to. It's just more complicated. So the number of moles here, 0.11 moles, goes with the 2.1 liters. This is volume. I can calculate volume 2. What bothers me about this question is it's not real obvious. Was all of the gas used up, or what's going on with that? We're going to go with the simplest explanation and say that this is the final moles of gas, and this was the initial moles of gas. We're not going to worry about it. Yeah.
why is it deep in volume 2?
Because I screwed up. It's volume 1. Thank you. I wish I could say I did that to test you to see if you're paying attention, which you are. But no, it's just me being dumb. I do dumb stuff too. Everybody does stupid stuff. Does it make you stupid? No. Just admit it, laugh, and go on with your life. Okay, did I screw anything else up? So here we have N and V. So we need Avogadro's law. V1 over N1 equals V2 over N2.
In reality, though, are you really missing the 2? Is that 2.1 is the initial?
I'm missing the final volume.
Okay.
Yes, I am missing the final volume.
Okay.
But the way I labeled them,
I just want to make sure that
Yeah.
I labeled it.
yeah, you can label it differently. That's absolutely fine.
Okay.
So cross multiply. I'm looking for V1, divide by N2. V1 equals N1 V2 over N2.
In a test, are you giving us these?
On the hour exam, I will give you all of the gas laws. You need to pick them out and be able to rearrange them. On the final exam, they will not be given. Yeah. So we'll put the numbers in here. 0.58 moles times the second volume. That's a decimal point. Divided by N2.11 moles. Yeah, instead of thinking of these as the first condition and the second condition, think of this as the first numbers I came across and the second numbers I came across as the problem was written. And if you want to label them differently, that's fine. Moles cancel out. 0.58 times 2.1 divided by 0.11. So volume 1 must equal 11.07 liters. I should have 2 sig figs, so we're going to call that 11 liters. Any questions? It may look easy when I do it. You need to go home and do it yourself. Watching someone and doing it yourself are very different. The wording can be confusing, yeah. And so, one way to practice this before you start doing the homework assignment or something is find the YouTube video, pull it up, and then pause it right where it just shows the question and do it yourself. And then play forward and see if you come up with the same answer. You don't have to come up with it exactly the same way I did, but you should end up with the same result.